My name is Alex Christensen. I'll be presenting on behalf of myself and Michael Denbina, the digital elevation model. So this is actually a product that's not yet available on Oronel. So this is what it will look like when it becomes publicly available, but right now it's still in preprint and we're still making a few updates, which I'm going to talk about. So the main products that this will include are a new water mask. This is different than the one you saw earlier from UAVSAR. The DEM itself, which we're hoping will be used in the models and other users can use for their own purposes. And then also a data source flag. So this will tell you where the elevation data comes from for each pixel, or at least where there could be more than one data source, but so the main data source it comes from. Just for everyone's reference, the elevations are in meters with respect to NAVD 88. The coordinate system is in UTM, which I think many of the files we've seen here today are. And the spatial resolution for the DEM is 10 meters, though not all of the data sources are originally in 10 meters. So the first product is the water mask. So this is water versus land classification. It comes mainly from the National Agricultural Imagery Program. So this is an aerial program that takes imagery every few years. It's at a 1 meter resolution, so we've resampled it to 10. And using these images, we calculate a normalized difference water index using the green and near infrared bands. And then we set a threshold for classifying water versus land. So we have data from 2010, 2013, 2015, 2017, and 2019. And for each of those years, we calculate a water mask, and then we make the final product of permanent water body for any pixel that is water for at least 3 of those years. And then there's some areas that don't have NAPE data, and that is supplemented with Sentinel-2 data, but that's a pretty small area. And then we've also been making some manual corrections that people have pointed out, some channels that are missing, important channels that are missing, and areas that should be water but aren't. So then to build the DEM, I'm going to walk through each of the main data sets that we use to build this. It's quite a compilation from different sources, including some that have been collected as part of Delta X. But so for the topography, so anything that's identified as land in the previous mask comes from the USGS National Elevation Dataset. So this is LiDAR data. You can see here what year the LiDAR data was collected. So some of it goes back to 2012, and some is as recent as 2017. So these are maybe not the most recent data sets, but it's what has the best coverage for the coast of Louisiana. So this is what that looks like for elevation. So the brighter yellow colors are higher elevation, as you expect. And again, everything is in meters with respect to NAVD 88. So for some of these areas, we have LiDAR data collected as part of Delta X. Specifically over the Wax Lake Delta, the Caltech team had LiDAR surveys done via NCALM. So this is from winter 2020, I believe. So this for this area of Wax Lake, we have updated the USGS LiDAR using this LiDAR. We also collected LiDAR over some of the other intensive sites, and those are still being processed, but will eventually be included in a future version of the DEM. So if we switch to bathymetry, the baseline bathymetry is set using the USGS/NOAA CONED, or Coastal Elevation Dataset. This has been compiled over many years. You can read more about the data set and where all of the data come from if you're interested. And then we also have included some bathymetry from Xing et al. 2017, which is another compilation. So if you want to know exactly where each pixel data comes from, I recommend you check out those sources. So that's the baseline, and then we kind of update or improve specific areas where we have data available. So for lakes, these are identified via SWOT using the Priority Lake database. This is not yet publicly available, but it will be soon. So this is part of the SWAT satellite program. Anything that is a lake, we carve to at least 2 meters unless other data are available. So anything in the blue colors here. The two darker blue colors, we actually have some bathymetry from CPRA. So that's the System-Wide Assessment and Monitoring Program, or SWAMP. So these were surveyed, I believe, in 2019. So the list of the lakes are here, and that's all available publicly. So those are updated using these, and that's interpolated using an inverse difference weighting algorithm. Other areas we have more data, of course, are the Wax Lake Outlet. This is commonly surveyed, and the Wax Lake Delta. So we have quite a bit of data from here. Within the main channel and portions of the intracoastal, we have sonar data collected during the pre-Delta X. So this would have been 2015 or 2016, shown in the blue. And then in the Delta Front, that comes from Shaw et al. 2016. And I think that's one of the more comprehensive multi-beam surveys that have been done. And I'm sure that there are others who are continuing to update these. So there will be updates in the future. For the Terrebonne Bay, so this is a fairly large area that is difficult to survey because it's a lot of fragmented marsh. This comes again from the CPRA Swamp Program. So from 2019, this I think was a huge improvement for us, for the DEM in general, because there's not a lot of great data in this area. So having that has been really useful. And again, this includes a few channels, but is mostly within the main Terrebonne Bay. And then what Delta X, the most recent Delta X campaign contributed was just updating some of the channels that we traveled just for doing other field work. So this was collected in spring and fall of 2021. So anywhere that one of our research vessels went, we had a sonar collecting bathymetry data. So you can see where those channels are here. Again, they're mostly channels that are navigable by boat. So we're not necessarily capturing some of the small channels. So then the question is what to do about the small channels where we have no data. Essentially, anything that was defined as a channel from the water mask, but we don't have bathymetry, is carved to 2 meters or negative 2 meters NAVD 88. You can see from this figure that the water mask is capturing channels that are at least 30 meters wide, but anything smaller than that is not captured with the water mask. And so we're losing all of these little pieces here. Maybe not the whole channel, but they're often disconnected. And so I know that can make it difficult to be used in the hydrodynamic models because then you lose that connectivity. And this is something that we're trying to improve, possibly, on a case-by-case basis, or maybe with the UAV STAR map or some other data source in the future. And then one other data set that we recently discovered covers water bodies in the National Hydrography data set. So this is from a paper in 2022 where they took a lot of different data sets. You can read about each of them, but essentially all of these water bodies in yellow have a mean bed elevation. And so if within our DEM we didn't have good bathymetry, we're just taking the mean elevations from these. And that's particularly important in 6 Mile Lake here, and some of these other lakes in the northern part of our domain. So finally, this is the data source flag. So this shows you where each pixel's main data source comes from. So you can see the variety of data sets I just went through. Anything that is -1, which is actually very small, but I guess there are a few of them, means that it's 50-50 split between 2 different data sources. So that means there's not one dominant data source that it comes from. Yeah, so you can see there's quite a bit of variety, and there's been a lot of kind of averaging or smoothing to make all of these fit together seamlessly, and that has been done by Michael. And this is the final product. Again, not yet on Oronel, but will be hopefully soon. So you can see it's beautiful. Yeah. All right. I think that's it for me. Yes. Oh, here's some references.